Unit 4, Lesson 5 test. Number 1. Rika conducted an experiment with a radio-controlled toy car. The sketches show her findings. What is the average acceleration of the car? A. 5 meters per second squared. B. 10 meters per second squared. C. 15 meters per second squared. D. 20 meters per second squared. Number 2. A car travels in a straight line. The driver applies the brakes and comes to an abrupt stop. During braking, what happens to the velocity and acceleration vectors? A. They point in opposite directions. B. They point in the same direction. C. They are at right angles to each other. D. They create centripetal acceleration. Number 3. What is acceleration? A. The direction of motion. B. The rate at which velocity changes. C. An object's speed multiplied by its mass. D. The rate at which an object's position changes. Number 4. Measuring acceleration requires appropriate units. Which are the SI units for acceleration? A. Newtons. B. Meters per second. C. Meters per second squared. D. Kilogram meters per second. Number 5. Katrina rode her bicycle to the library. The following graph shows the part of Katrina's ride after she started. What was Katrina's acceleration during the time represented on the graph? A. The acceleration was 0. B. The acceleration was 10 meters per second. C. The acceleration was 10 meters per second squared. D. The acceleration was 3.3 meters per second squared. Number 6. Which of the following is an example of an acceleration vector? A. 5 meters per second. B. 5 meters per second squared. C. 5 meters per second squared south. D. 5 meters per second south. Number 7. How can you find the average acceleration of an object? A. Multiply its mass by its speed. B. Divide its distance by the time it took to travel that distance. C. Subtract the final position from the initial position and multiply by the change in time. D. Subtract the initial velocity from the final velocity and then divide by the change in time. Number 8. Elizabeth is a wildlife biologist. She traveled by boat in the Everglades to observe alligators. The following graphs show the motion of her boat at several times during the trip. Which graph shows her boat traveling when it is not accelerating? A. Graph A. B. Graph B. C. Graph C. Or D. Graph D. Number 9. An experimenter records data for the speed and time of rolling carts along a straight track. The table shows the data for 4 trials. In which trial did the cart experience the greatest average acceleration? A. Trial 1. B. Trial 2. C. Trial 3. D. Trial 4. Number 10. Which is an example of centripetal acceleration? A. An object at rest. B. An object moving in a circle at 20 meters per second. C. An object moving 20 meters per second backwards and then 20 meters per second to the right. 20. D. An object moving in a straight line at a steady speed of 20 meters per second forward. Number 11. An experimenter records data for the speed and time of rolling carts. 4 different trials are conducted. The table shows the data for all 4 trials. In all trials, the cart accelerated. In 3 of the trials, the cart moved in a straight line. In which trial did the cart experience centripetal acceleration? A. Trial 1. B. Trial 2, C. Trial 3, or D. Trial 4. Number 12. Which of the following describes an object moving in a circle steadily? A. Change in speed only. B. Change in direction only. C. No change in speed or direction. Or D. Change in speed and change in direction. Number 13. Number 13. Which scenario does not describe an example of acceleration? A. A car increases its speed while turning to the left. B, a car decreases its speed while driving straight ahead. C, a car maintains a constant speed while turning to the right. D, a car maintains a constant speed while driving straight ahead. Number 14. Julia is in a car with her father. The car is undergoing just centripetal acceleration. What is happening to the car? A, the car is changing direction at a constant speed. B, the car is changing direction and speeding up. C, the car is stopping suddenly. D, the car is slowing down. Number 15. For an investigation, a student measures the speed of a cart as it rolls down a ramp. The student then records the data shown. It is traveling 10 meters per second at point A and traveling 50 meters per second at point B. It takes the cart 4 seconds to travel the distance between point A and point B. What is its acceleration? A, 4 meters per second squared. B, 5 meters per second squared. C, 10 meters per second squared. D, 30 meters per second squared. Number 16. For an investigation, a student measures the speed of a cart as it rolls down a ramp. The student then records the data shown. It is traveling at a speed of 200 meters per second at point A and is traveling 50 meters per second at point B. It takes the cart 5 seconds to travel the distance between point A and point B. What is its acceleration? A, 10 meters per second squared. B, negative 10 meters per second squared. C, 30 meters per second squared. D, negative 30 meters per second squared. Number 17. If speed equals the distance traveled divided by the time taken to travel the distance, what will the units be for speed of a car that travels 2,450 meters in 50 seconds? A, meters. B, seconds per meter. C, meters per second. D, 49. Number 18. What was Katrina's acceleration during the time represented on the graph? A, acceleration was 0. B, acceleration was positive. C, acceleration was negative. D, cannot be determined from the graph. Number 19. In a swimming race, Miho swam the first 50 meters in 42 seconds. She swam the second 50 meters in 40 seconds. What was Miho's average speed during the race? A, 0.82 meters per second. B, 1.19 meters per second. C, 1.22 meters per second. D, 1.90 meters per second. Number 20. What is the definition of mass? A, how much something weighs. B, a measure of the amount of matter in an object. C, how much space something takes up. D, the ratio of the weight to the volume.